Moving on, I want to make sure that we had plenty of time to kind of discuss this. Insulation, I was talking with Connor. Connor had thrown out, well, you know, would that be integument? You could blame a little bit of this on integumentary system. Something else I'm thinking of more so. Can someone name that item? Okay, more specifically. Fat. Adipose tissue. Insulation. Circulatory or circulation adaptations. What would you be doing circulation-wise that could be modifying your temperature? Always pumping blood, though, so let's be specific about the mechanism. Um, I think we're on the right track. To address Austin's point, it could be that you increase the heart rate. I mean, like as you're very, very cold or actually just really cold, you'll pump blood faster typically. But what I'm thinking is something called vasodilation and vasoconstriction. When you vasodilate, the blood vessels become large. They'll go a little bit more on the outside. But when you're very, very cold, it doesn't. Everything constricts down. The blood vessels go more interior. They stay more inside the body, if you will, to keep the heat at the core, more so than on the outside. Vasoconstriction, vasodilation. There's evaporative cooling, which is going to be all about like sweating. We already mentioned that. Behavioral responses. Now, this is anything that involves mental decision. So, like, Austin had said, the insulation could be the coat. And I would say, well, even though a coat does serve as an insulating material, that's actually more behavioral because you're deciding to put on the coat. So if you decide to go inside because it's too warm, that's behavioral. Ooh. This is all about thermoregulation. This shouldn't be like that's. I guess you would put like if you were to randomly walk into a fire, then yes, you would walk out of it because of behavior. But this is all about like internal body temperature. Like this is not like based on environment. What can your body do? I guess if you were in a fiery environment, you would run out. That'd be behavioral. Yeah. Oh, you built a fire. Oh, I thought you said you were in a fire. Oh, okay. I was like, yes, yeah. If you build a fire, that's still behavioral too. Definitely building a fire. I just imagined someone woke up and they were like on fire, and I was like, that would be horribly bad. Go ahead.
Okay, so would like shivering and goosebumps not go with this?
I would say no. That's going to be more of a circulation adaptation as well as a metabolic rate, because what you're doing, honestly, is you shiver. Is think about what's happening. Are your muscles contracting or not? Okay, so as you shiver, your muscles are contracting. Now, when muscles contract, does that need or not need ATP? Any muscle movement will always need ATP. And we've already agreed that as your muscles move, they need more ATP. So you're going to drive this reaction more. That would be like driving further in your car, not so you could go further distance, but so that your car became warmer so you could get warmer. Does that make sense? Your body shivers and moves its muscles to drive this reaction, which you shiver, you need more ATP, but as you do this, you generate excessive heat.
Like starting a car before you go out to it to do this.
Basically. Yeah. I mean, it's just like a way to prep. Yeah. So I would say that would be more metabolic rate manipulation in the case of shivering or having goosebumps or whatever. You could put it a little bit under circulation. So those right there are some of the things that you could be doing, whether it's by choice or not, to regulate like your internal environment.
What was the metabolic rate?
Metabolic rate would be basically changing this strategy up. So causing like shivering. Shivering is a way that you generate a higher metabolic rate. I mean, so in other words, I'm saying that when you shiver, you're burning it's like exercise almost. Let's see. Your book gets into a little bit about something about bioenergetics, where they talk a little bit about like what metabolic rate is and what BMR versus SMR is. Have y'all ever heard of BMR before? Never heard of that? I at least should talk about that. Y'all haven't? Do y'all have to take health at all anymore? You do? Y'all didn't talk about this in health though? Okay, well let's talk about BMR. That is your basal metabolic rate. And that basal metabolic rate is going to be all about is the metabolic rate of an endotherm. At what we would call a normal temperature. Now it works out, obviously as you get larger, you need, like, there has to be a higher BMR, and I say not you personally, I'm saying like the creature. So like per kilogram your BMR goes down. In other words, elephants need more energy, but they don't need as much per pound or per kilogram as a mouse does. So it works out in such a way that humans typically need about 2,000 to 2,500. And I'm going to write big C, which stands for calorie, which actually is 1 kilocalorie if you think about it from a chemical perspective. Really, this basal metabolic rate is just, and honestly, I probably should put this. I should put this lower. That's probably a little too high. This might be for a teenager. It more likely maybe would be between 1,000 and 1,500 for an adult. For a teenager, it might be a little bit higher. Thinking of like 18-year-old male. 18-year-old male would be about 2,000 calories for basal, because this right here accounts for about 60% of all energy needs. The other 40% of your metabolism is dedicated to like thermoregulation, reproduction, cell growth, stuff like that. Well, let's talk about not maybe necessarily. Well, actually, you know what? We'll talk about this from the context of your cereal. Life sounds like the type of cereal that would be healthy for your life, right? I mean,
Not like Lucky Charms.
it's not a Lucky Charms for sure. So
That's
this,
what
it's what?
That's what I ate this morning.
You ate Lucky Charms?
It's
Um,
good for the soul.
Yeah, I guess those are the ones with the little marshmallows, is it not? Okay. Well, I don't want to talk about that because that's too many carbohydrates. I want to talk about something that's got just all of the food groups in it. Okay. This right here is chapter 41, which is all about your digestive system. And there's really no easy way to break this down. As far as our process, you mean we just really have to go through everything in detail. Now, I will say that we could go over some very, very general intro stuff real quick that we probably already know. Like, for instance, the fact that food, Nutri-Grain bar, is converted into CO2 plus H2O. And there's a release of energy, correct? And that energy forms what? Okay, ATP as well as heat. We had just mentioned that. This was respiration, an exergonic reaction, one that was spontaneous. Hopefully, is it aerobic or anaerobic? Okay, hopefully it's aerobic. Hopefully you're breathing. And that food can come from a variety of macronutrients or macromolecules. Now, when I think of your variety of macromolecules, I think of the proteins, the carbs, and the lipids, and how they fit into that concept of cell respiration. However, if you look at any of these guys in the world, like literally in total, there are millions of different ones of these, but your body only needs some that are what we call essential. So your true need, and when I write true need, I mean like what you have to have. You have to have your essential amino acids, your essential lipids. Seems weird that there could be a fat that's ever required, but there is some fats that are required, or there are some fats that are required, and basically carbohydrates. And I don't want to say the essential ones because everywhere you turn there's a carbohydrate, so it's unavoidable. I say that the essential amino acids and essential lipids because there are diets or body strategies or diet strategies that allow people to not have hardly any amino acids ingested or any lipids ingested. But carbs you just really can't avoid. Everyone's eating a grain. Good? That's why you try to limit carbs, yeah, typically. And you also see that you can remember from back in the day that carbs can be converted back into fats pretty simply. So another reason why you would want to avoid. What your body does, the reason these are called essential, is that your body has the opportunity, or the body has the potential to convert these to a usable form or another usable form. So these guys can be converted to something else that may be helpful. Now is also a time to talk about the importance of vitamins, which are helpful enzyme-like units. These guys are there to facilitate or enhance the biochemical reactions. That exist out there. So really, your true need would also include vitamins as well. And we might as well say that another one of your true needs would be minerals out there. Because a lot of times your minerals act as cofactors. And these cofactors work with the body's natural enzymes. These two are very required. Now, of course, in the event that you are lacking any one of these, if you're lacking a certain amino acid, there's a chance that you can interconvert it. But if you're lacking something that is like a stringent requirement in your diet, then of course you're going to have problems. And there's two words that I want to identify here. I want to identify the term undernourishment and the term malnourishment. Undernourishment is going to be when you have basically not enough food, so a lack of food. This could be because of the conditions that surround you, you know, what area of the world possibly. It could also just be like choice. Malnourishment is going to be missing one or possibly more of the vital nutrients. And that would include any one of the essential amino acids or vitamins or minerals. Cool. People that are typically undernourished, they're going to have a couple of unique conditions. Some of the things that they might experience would be a lack of muscle, perhaps, possibly organ failure, as the body attempts to break down its own stuff. Obviously, there's going to be a quick use of any body reserves, and then post the use of body reserves, which wouldn't exist too heavily on someone that has been undernourished for a long period of time. They'll start to break down their own body muscle, and they'll break down their organ proteins and carbohydrates, which of course would lead to organ failure, would be a very negative thing. This is the type of stuff that affects countries that are having a crisis with food management, basically. Malnourishment, you would think, well, if you're just missing one little piece, it could be worse. You could be missing them all. But typically, malnourishment is just as bad. You could go back to the picture of the lady with the goiter. Do you remember that picture? The goiter on her neck. That was missing iodine, which you need basically hardly at all, it would seem, but you need it. Typically, though, it's very hard to find these in irreversible form. So typically, these are reversible with diet change. In rare cases, it could cause deformities, possibly disease, maybe death, but it's got to be it's got to be something very important that you're lacking. Out of all the things that you are malnourished, there's only a couple that would cause death or other severe illnesses. Cool. Awesome. Now, we've talked about a couple different feeding models, and I'm not going to really go through these because to me it's not like a big thing to address. I don't think we really have to be detailed about the different types of feeding. I mean, you've seen filter feeders before. We've mentioned them, like with Peripera, the sponge, right? We follow a totally different model. We follow a model that is all about like an inside digestion. Good? Okay. Is everyone awake? Good. Digestion, absorption, and elimination. Like your three-step process that basically has to occur. Digestion. What is this going to be? Okay, so let's be very specific, or as specific as we can be right now. Mechanical and chemical breakdown. Of food into pieces. Hydrolysis proceeds through enzymatic actions. And what do I mean by that? What is hydrolysis? Do you remember? Hydro, water, lysis, split. Yeah, I heard of that over there. Splitting with water. Would this split, would that be build up or breakdown, do you suspect? Okay, so this is, breakdown of food. Hydrolysis, the use of water does this. Now you know why you have to drink water within a week, but you could go without eating for 4 weeks, right? You die of thirst before you die of hunger, correct? Do you know why now? Because your body will start to break down itself, which is not fun, but it can do. But only if water is there to allow for the hydrolysis. Absorption. This is basically going to be an uptake of nutrients into the bloodstream. And we might as well mention it now rather than later. The absorption is all going to be about the small intestine. So I'll definitely just want to make sure that small intestine is where it's going to be at. Then lastly, elimination, which is going to be the removal of undigested material. Cool. The removal of undigested material. basically your large intestine, which has it's broken up into sections, and basically your sections are all referred to as the colon. So when they say colon, they're really meaning the large intestine, which is basically the spot of holding before elimination. You obviously know where I'm going with that. Your book gets into like the different types of digestion, if it's intracellular or extracellular. Obviously, we have like a compartmentalized digestive process, one that begins like in the mouth and terminates with the rectum. So I don't think we're really going to go anywhere in huge detail. What I want to do though, and this will be like my last little bit, you can kind of copy this down real quick and then we can be done with this stuff. This is my last little bit for today. I know we don't have a lot of time, and this is very detailed. You know, you can make it kind of happen, though, right? Anything's possible with a little bit of magic. I'm not a fan of Harry Potter, but I believe in magic at least. You probably could draw that.
What exactly are we drawing? Like the circle?
I really need you to draw this guy right there. So there's that. I need you to draw this guy right there. The big piece that you're seeing outlined right about there. Looks like a question mark, actually, if you think about it. And in fact, that's what the large intestine is. Like it's a big question mark. And then right through here, you can just, like, these are little wavy pieces, your little small intestines. That pipeline running down. Mouth area. This is really just a very general overview. I don't need these two pieces right there or right there just yet. We'll talk about those tomorrow. And most of these places are very, very simple. Want us to just make sure that we can identify what structures are most important right now. I've got the large intestine there. In the middle of that, there's the small intestine. Above that is the liver, the stomach. Obviously this pipe, we're not going to label it pipe though, it's going to be the esophagus. You ever had heartburn before? Once? Heartburn, the esophagus connects down to your stomach. So if the acid from your stomach accidentally travels back up because the cardiac sphincter, which is right above the stomach, is malfunctioned, then acid could travel back through, and it gets to about right this point. Gravity is kind of a problem a little bit, and that's about where your heart is. So you think it's oh, my heart's burning. Well, it's not. It's actually your esophagus burning because of the acid. And right there is your. Right there's the mouth. Did someone sneeze? Mouth there. Cool. And what we're going to do, oh, don't forget, gallbladder, right below the liver. I don't see the pancreas drawn on here. I could be missing it, but I just don't see it drawn. A little bit. So we'll include that at some other point. I guess we'll just talk about that tomorrow. But anyway, this general drawing we will break down more so tomorrow. And tomorrow we're going to go through the detail of how do we start here and end up here. Thank y'all.